Hi everyone, my name is Michael Brockman and I'm an architect at IBM Cloud. As you probably know, IBM's cloud strategy is completely based on a multi-cloud approach. IBM's Red Hat acquisition has strengthened our leadership position in this domain, Red Hat OpenShift being the core but definitely not the only technological foundation for this strategy. Now, in nearly every customer engagement I'm facing, multi-cloud is not a buzzword, but reality. But multi-cloud today is often not a purpose or by purpose architected pattern, but rather a state that has been achieved through organic cloud adoption of various entities or business units in the enterprise. Now, a multi-cloud architecture that is designed by purpose can bring a lot of value, but requires careful planning and also embeds some complexity. Based on some of my real-life engagements, I have summarized key questions into 8 domains or areas that you need to ask yourself if you want to head into the same direction. Regard this video as a kind of guideline. Its intention is not to give you all the nitty-gritty detailed answers to all questions being raised. So let's get started. So I have clustered the questions into 8 areas or domains, starting from the fundamental question on what you want to achieve by getting into a purpose-based designed multi-cloud solution. From there, I cover various areas crossing governance models, how to plan for commonality within the technology stack, questions being raised regarding the application architecture, security, your deployment strategy, as well as finally the intended day 2 operations model. Is this drama really necessary? This probably sounds a bit provocative, embedding a notion of complexity to some of you. But I really should make you think about on why you're intending to invest into a multi-cloud architecture. Know your reasons. One of the most obvious reasons is provider independence. Avoid falling into the hands of a single provider by leveraging proprietary technology that prohibits moving to another provider or at least makes the effort to move a very large one. Think of bringing your workloads into various providers with minor differences. Honestly, smaller differences will always be there, but you can reduce them to a minimum, bringing in a kind of natural exit strategy. Regard portability simplification as a consequence of what I just mentioned about provider independence. If you can deploy your workload on various cloud providers' platform with minimal changes, then you have done a great job. But this requires careful planning within the technology stack that your workload is based on. Choosing proprietary technologies and services out of the cloud provider's service portfolio will definitely not be the way to go. Choosing open source technologies will be the only way that you'll achieve the goal. Another reason I see is purely commercially driven. Enterprises not only want to control their costs, but also determine where to run their workload the most cheapest way. Again, this requires that your workload is portable and deployable to different cloud provider platforms. If you can answer this question with a yes, brokering between different provider platforms and seeking to achieve the lowest price is definitely an advantage multi-cloud can provide. Another driver, you want to pick the cherries from the various providers in order to follow a best-of-breed strategy, like choosing Watson AI services from IBM, others from other cloud providers' portfolio which you regard stronger for building out your project needs. You can do that. That doesn't necessarily mean you need to lose a commonality between the providers' platforms. It might be that specific for most industry-specific requirements can be better addressed by some providers than others, so that multiple providers become a natural consequence rather than a designed target. IBM Cloud, for example, has a strong focus on financial industries, as you probably heard with the announcement of IBM and Bank of America. The IBM Cloud for Financial Services addresses some of the most challenging compliance requirements, all controlled and regulated through a technology-based cloud policy framework. And finally, as in every larger enterprise, there is often not one overarching entity that defines the way to go. I've seen it too often that various IT or specifically business departments select cloud services fulfilling their most urgent project need. In the end, this results very often into an organically grown multi-cloud environment, but without any relation between the various cloud entities. I'm not saying that this is a bad way to go, but proactively aiming towards a real multi-cloud architecture with alignment across providers requires some planning and overarching decision-making, usually as part of the Cloud Competence Center, which defines at least some guardrails. Now, there might be other reasons, but these are usually the most obvious ones we can see depending on the answers, and favorites result into different multi-cloud approaches, which I now try to address. The first pattern today, probably the one you see most often, is a pattern of complete isolation. Providers get selected based on a specific workload need. Office 365, some Salesforce CRM SaaS solution, developing an AI Watson-based containerized workload inside the IBM cloud, just to name a few examples. All with a relationship or no relationship, between each other. Again, this is a pattern that is organically created or achieved rather than being architected by purpose. Multi-cloud and hybrid are too often put into the same bucket, which they are not. Hybrid is an architectural approach in favor of workload needs, integrating parts or components which are spread across different places together in favor of the resulting application or workload. Let's take a simple example here. You have a containerized web front end running off-prem in the public cloud while keeping your data for security or compliance reasons on-prem, either in a legacy mode or, as in this context, in an on-prem cloud instance. It might also be that parts of the application are split between different provider platforms. For example, hosting the containerized workload on IBM Cloud in a managed OpenShift environment and attaching, to use the term of the 12-factor app, that to some services on AWS. It might be that applications on 2 or more cloud provider platforms need to exchange data or messages and by that define their interdependency requirements. The point where it gets the most interesting out of an architectural and value proposition point of view is when there is a specific commonality across provider platforms. Why? I mentioned drivers like prevention of vendor lock-in or portability of workloads between providers. This is exactly where Red Hat OpenShift finds its sweet spot. Even if the application and attached services still uniquely selected on the provider platforms, the runtime layer is equal on all platforms. So OpenShift is OpenShift is OpenShift. As a developer, you'll find the same bed that you lay your application into. There might be smaller differences from platform to platform, but they are addressable. So there is a difference in favor of your multi-cloud strategy if you would choose OpenShift as a common runtime layer, rather than selecting the native container services like IKS from IBM, EKS from Amazon, GKE from Google, or AKS from Microsoft Azure, you name it. If you're aiming at a full portability of the complete technology stack or of your application or workload, then you not only need a common runtime, but middleware as well as your application code. Your microservices all have to be in a portable package. As IBM, we can help you here. This is exactly what we address with our so-called cloud packs, which are containerized middleware packages sitting on top of the OpenShift runtime, independent on the underlying cloud provider platform, or even on-prem in your own private cloud instance, as drawn on this picture. So governance, how do you control all of what you are doing across clouds? Leave it to the consumer of the various clouds, or are you setting guardrails in some form in a kind of central governance? Before we get into more technology-oriented aspects, let's have a view on the governance model. The key decision, again, aligned with the type of multi-cloud philosophy I was addressing already, is a decision of a central or decentralized governance model. In other words, will decisions be done corporate-wide, for example, within the responsibility of a cloud competence center, Or will you leave all decisions decentrally, for example, within a business units or projects governance scope completely free in their decisions? Another decision point is if and how much of operations responsibility you're exposing to the cloud provider, either as part of the cloud services being used or as additional operational services on top of the cloud service itself. We as IBM offer complete multi-cloud management services across all major cloud providers if you want to outtask responsibilities. This might even include aspects like being part of your DevOps SRE team setup. Think about how you would compare and consolidate billing and costing information across providers, potentially even offer a brokerage portal that allows your internal consumers to decide where to order a specific service in the mesh of the various cloud providers. So coming back to the point of a central governance model, specifically tech stack decisions should be centralized. Projects should then work along these guidelines without taking them the freedom for specific decisions. Experts, developers, operations-focused SRE teams, etc., can and will move between projects. The more commonality you have from a tech stack perspective between the different cloud provider platforms, the more flexible the exchange of the teams can happen as well. Let's now have a look into the more technical decisions you need to take in a multi-cloud approach. The key question here being, how much commonality across the different cloud providers will you plan for? The least common denominator is the runtime. In this example, Red Hat OpenShift, which is available on all major cloud providers, which gives you as a developer the same user experience. In addition, you need to decide if your runtime needs dedicated or shared characteristics. In other words, does the OpenShift cluster have to be dedicated, or is it sufficient for your applications to be based on a shared or multi-tenant cluster model? The main difference being the commercial attractiveness of the shared approach. In IBM Cloud, we shortly provide both models. You can attach native cloud provider specific services to your microservices you are deploying into the container runtime, depending on the functional needs of your application or project. You can also leverage the concept of OpenShift Kubernetes operators to deploy your middleware services yourself and bind them to the applications deployed into the runtime. So even if you choose to bind cloud provider specific services to your application specific microservices, for example, like a database, messaging, streaming, or AI service, try to agree on a common technological selection. This will allow you to keep the portability developer experience higher rather than leveraging proprietary services on the platform. In favor of these technology decisions, I have used quite successfully a kind of domain model comprising all areas of a typical cloud-native application. Try to agree on technologies, open source being in favor for specific service areas within this domain. I have highlighted in red some exemplary decisions, like Red Hat OpenShift for the container runtime, Istio as a service mesh implementation, Knative for serverless applications on top of OpenShift. Walk through the model and customize the model if needed, and try to decide which technology you would like to use across providers and which is also available across them. This doesn't shield you from slight differences between providers, but portability and compatibility gets easier in the end. Another decision after you select on the technology itself is if you want to leverage the services as usually provided by the cloud providers as managed services, or if you want to implement services yourself on top of an infrastructure as a service stack as software and take care of this of the service then yourself. Both approaches have pros and cons. Taking the managed PaaS services from the provider takes all the hard work away from you. You just consume it and throw it away if you don't need it anymore. And you only pay by consumption based on what you need. But usually the way the cloud providers implement have slightly differences you have to deal with. If you want to mitigate these differences, use operators to implement these services on your own on top of Kubernetes or OpenShift clusters. But you're in the role of the provider at this point, so that's a decision you have to make. If you want to have the same user experience, the same stack across all providers, you can do that with the help of IBM Cloud Paks. They are providing containerized middleware stacks on top of Red Hat OpenShift and provide the exact same backing service layer across all providers. The downside is you're in the driver's seat of installing and operating them yourself, or you have an external partner that who does that for you. Now, there is another way of bringing a whole stack portability across different providers, and this is by leveraging a distributed cloud approach. In IBM Cloud, we will shortly make available IBM Cloud Satellite, our public cloud being brought to any infrastructure that you provide. So how does that look like? You provide infrastructure according to specifications that we will provide and register your environment as a satellite inside IBM Public Cloud. You specify which cloud region you like to connect your satellite to, for example, Frankfurt, which establishes a so-called satellite link. From the public cloud environment, specific control plane services get deployed into your on-prem environment, as well as the services you select from the public cloud catalog that you want to deploy and leverage into your satellite. The same SRE team that manages the cloud service on the public cloud takes care of the service that now has been deployed into your data center or wherever your satellite infrastructure is hosted. In other words, the IBM public cloud gets a new location choice type. Rather instantiating your service in Frankfurt, Dallas, Tokyo, Sydney, or wherever you want it, you now select your satellite as a destination. The rest is completely the same. You can select infrastructure on other cloud provider platforms as well, like AWS, Azure, Google, or you name it, and make an IBM Cloud Satellite destination within these environments. So coming back to the multi-cloud approach, this gives you another way to have the same stack deployed across various providers. So let's have a specific view on some aspects of the application and architectural aspects, which for sure are highly related to some key decisions around areas we already discussed. You'll find me repeating things, which is okay, given specific areas are simply interrelated to each other. So in terms of your applications or microservices, the question is your application itself leveraging multi-cloud aspects? And if yes, how exactly are you planning to do that? Again, the type of multi-cloud model or pattern that we already talked about will be highly interrelated. The same is true for the tech stack discussion we had earlier. There are three types of an application perspective: isolated, distributed, and redundant. So isolated, your services are isolated in the sense that they are bound or built to a specific cloud provider's platform, as highlighted on this diagram here. Distributed. There might be cases when microservices of one application have, should, or need to be split into different cloud provider platforms, resulting into a kind of hybrid architecture. This might be the case when applying something like a backend for front-end or BFF pattern, where specific backend implementations are encapsulated behind specific APIs or on another platform as a front-end, probably also resulting based on legacy reasons. Another reasons might be a split between an on-prem and off-prem runtime environment. And finally, redundant deployment, where the same services get deployed to different provider platforms, which would require a degree of commonality between the providers, what we discussed during the tech stack section already. A reason being distributing the load and on specifically the risk between providers to increase your resulting availability, for example. We talked about a common runtime as a least denominator across provider platforms already. Now, Usually, specifically in the cloud native world, developers like to pick different runtime models for specific needs. Kubernetes as a container orchestration environment, serverless running for short-running transaction, and commercially highly attractive or PaaS runtimes like Cloud Foundry for pushing apps with a high degree of simplicity to the underlying runtime. Usually, every cloud provider has its own implementation of these runtime models, which makes it difficult to find a common denominator inside the runtime layer. The good news is all of the runtimes are finally based on containers. Kubernetes usually, and that is true for the IBM Cloud, does play its role of the platform for platforms, being the underpinning of the different runtimes. Now, from a multi-cloud perspective, Kubernetes and specifically OpenShift clusters are harmonizing the different user experience and patterns into one platform. Knative, for example, to allow serverless models within Kubernetes. So this gives you further good reasons to consider OpenShift as the platform of choice across different cloud providers for your multi-cloud strategy. Another area of consideration is integration. Service integration. Do you have to integrate services between different platforms on-prem? Being a typical use case we see in a hybrid architecture, or attaching backing services on a different provider platform from your microservices. Picking best of breed services being a typical reason. Data integration. Do you have to exchange data, for example, messages between applications, your microservices which are running on different clouds, or do you have to sync data between data stores? Ask the question yourself. So constructing application accessing a data lake with support of appropriate backing services in one cloud provider platform, accessing data from multiple cloud providers, a typical use case, which I highlight now here on this fly-in based presentation. Network integration. In case you have multiple providers, you need to think about how to connect your on-prem environment to their presences. All of the providers provide private links, either virtual or dedicated with different line speeds. Think about leveraging an exchange partner that terminates your incoming connectivity and can connect the last mile into the appropriate cloud locations. What if you have to connect between clouds directly, as discussed before in the context of service or data integration? There are too many ways depending on the specific use case to get into more details here, but you will face aspects like private and public service endpoints exposing backing services, virtual private cloud connectivity, and potentially API management solutions being used for exposing specific functions or data behind defined interfaces. Security integration, something you definitely will face when going multi-cloud. So one aspect you won't be able to eliminate is that each provider has its own IAM, or identity and access management system, to control access to appropriate services on the platform of the provider. One possibility to add a harmonization layer on top could be to use infrastructure as code capabilities, like, for example, Terraform, which allows a kind of abstraction on top of the proprietary methods and implementations. One thing you could do is to integrate all your cloud-specific IAM systems into a central identity provider, specifically for adding single sign-on capabilities across providers. Most of the time, enterprises like to reuse their existing IDP for that purpose, given they have a tight integration into existing user management systems already. The same is true for applications running on the cloud, which need to integrate into an IDP for SSO purposes, single sign-on purposes. For sure, the IDP can also run inside one of the cloud environments, either as a service. All of the providers have such. IBM provides a service called AppID, or as a software component that can be implemented everywhere, like Red Hat SSO based on Keycloak open source technology. There are multiple options you have to think about in terms of the best option to select. And finally, without claiming for completeness here, think about your encryption strategy, including bring your own or keep your own key based on HSMs, so hardware security modeling systems. Are you planning to do that with a central approach, adding the hurdle to implement interfaces of the security components yourself? Or are you leveraging the appropriate systems within each cloud, accepting differences in functionality as well as different security levels the providers offer? IBM Cloud, for example, does provide a service named IBM Cloud HyperProtect Crypto Services, which is a dedicated key management service and hardware security module. It is designed to enable you to take control of your cloud encryption keys and cloud hardware security models, and is the only service currently in the industry built on FIPS 142 Level 4 certified hardware. Complex wording here. And finally, for the integration topic, is there the benefit of an API management solution to manage and expose APIs on various platforms? Similar to the IDP topic, you need to decide where to run your API management solution. As a cloud service, as a software component, centrally, everywhere, in cloud, on-prem, all questions you need to answer and find answers for if relevant in your context. We actually covered most of the items within the security domain already. The key questions you have to answer is where to place critical entities like an IDP or HMS system. Are you doing that in your home cloud of each cloud, or are you sharing functionalities across providers as a kind of shared rental system? That's a key question you have to answer here. I addressed most of the topics already, adding some additional areas of concern here. How do you audit your activities across providers? Will you have a common logging facility for this? Will you adopt the Security Information and Event Management System, or abbreviated SIEM, across providers? How do we handle certificate management? Just to name a few additional questions. The rest we have covered already. Ask the questions. So continuous delivery is a given in the cloud-native world and requires 2 chains for deploying your code to your target landing zones. How do you handle that in a multi-cloud world? Even if I'm repeating myself, there are again interdependencies between the different aspects, what I have called domains. Also in this context, the more isolation between the clouds, the higher the chance that there is isolation between the pipelines as well. Where do you place or implement the 2 chain? Inside or in multiple clouds? Leverage it as a service or reuse what you probably have already in your own data center? Or do you want to implement specific toolings like IBM's Cloud Multi-Cloud Manager, which is based on Red Hat Advanced Cluster Management for doing and organizing things across clouds? Usually, this is very much dependent on the scope of the project, the affinity of business units or regional entities within the corporate to some cloud providers. If there is corporate governance, a cloud competence center that is able to define guardrails, a way to go within a multi-cloud world is to consider Tekton, an open source technology that not only allows you to define your pipeline as code and capture it inside a repository, but also allow portability by bringing the execution of the pipeline into the target Kubernetes or OpenShift cluster. You should consider it as an approach in your multi-cloud journey. Red Hat has implemented the Tekton technology as what they call OpenShift pipelines on top of the Red Hat OpenShift runtime. Getting into the last but not least important topic, operations. Day 2 operations must be a day 1 imperative. Still overseen in a lot of projects, even if dev and ops have come closer to each other as part of Agile and DevOps initiatives. Same decisions here, just for different purposes. Where to run and implement observability tooling like monitoring and logging? Or do you probably want to expose all of your operations externally? IBM, for example, provides not only appropriate multi-cloud management tooling, but also multi-cloud operation services where delivery units are managing your multi-cloud estate as a managed service. One of the questions will be, what the scope of your SRE team or teams will be. Is it related to a specific project or taking care of multiple projects which probably have been implemented across provider platforms, or is an external entity doing it for you, as mentioned already? And finally, infrastructure as code, don't forget it, should get into your mind as a way to provision cross-cloud providers. Terraform, for example, helping to abstract provisioning activities across all providers. I know, lots of questions you need to answer, things you have to cover. There's simply not one way to answer them. The first thing is, what do you want to get out of your multi-cloud strategy? That's a key question. Actually, we as IBM can help you not only with consulting services, finding your best path for your multi-cloud journey, but specifically with your open source-based technology. With our open source-based technology, Red Hat OpenShift playing an essential role as a common platform across providers, which can help you bring commonality across all of the cloud providers you are have decided for in your strategy. And if needed, we can also manage it for you or provide technology that allows you to manage your multi-cloud environment yourself. Thanks for listening.